Welcome back. In this video tutorial I am going to demonstrate how to use the craft add-in for Excel. It is given with this file, which is layout.xla. I'm going to show it in a minute, but before I'm going to explain it, demonstrate it with an example. Let me introduce you with the problem data. Let's assume that we are given 8 departments. For each one of those we are given the area requirements, or we identify these area requirements. So department 1 requires 200 meters square, department 2 requires 125 meters square, and so on. So in total, the total area requirement is more than 1136 meters square. The first thing we need to do is to represent each one of these areas with a unit square, with a cell. You can use 1 by 1, so 1 meter square, represent each meter square by a cell. In that case, for the first department you will need 200 cells. For the second one you will need 125 cells. So whatever the meter square, you represent it with one cell. And in total you will need more than 1000 cells. So this is a huge number, and you may want to work with smaller numbers, meaning that you increase the size of the unit square. So assume that we represent each 10 meters square by one cell. In that case, what happens is, for the first department you will need 200 divided by this 10, and since I'm going to drag the formula down, and you will need 20 cells to represent for the first department. So 20 cells, each one is 10 meters square. In total it represents 200 meters square of an area. For the second one, you see, you will require 12.5 cells. Of course 12.5 is not an integer number, so we will round it up and we will represent it by 13 cells. So if you do for each one of those, you will see that in the end you will need around 114 cells. Again, for non-integer numbers like this, we are going to round them up, but later on, when you came up with your final layout, manually you can adjust these to satisfy the area requirements. Of course, you can use, for example, instead of representing 10 meters square by one cell, you may decide to do it by 5 meters square. In that case, the area requirements will be doubled compared to 10 meters square unit cells, and in that case you will need 228 cells. Or you can increase even further and represent each 20 meters square by one unit, and then the total cell requirement will be less. Now we discussed about this, the trade-off between having smaller and larger unit squares. It is better to find or try different values and find a suitable one which is easy to handle, easy to solve, but not so easy to make the problem extra easy, or the final layout will not be realistic or representative of the real situation. So when the unit square size is too large, then each department will be represented by minimal number of cells, and in that case the final area might not be the best that you will find. So for this example, I'm going to use 10 meters square for each cell, and for each one of those I'm going to for each one of these departments I'm going to round them up and use integer numbers. The other problem data that we will need is the from-to chart, which shows the flow between the departments. According to this example, from department 1 to 2 the flow is 11 units, whereas from 2 to 1 it's 12 units, so it is not symmetric. And the empty cells here says that there is no flow from department 1 to 5 or 1 to 6. And if you are not given the from-to chart, but if it is a relationship diagram, a relationship chart or rel chart, which is the subjective evaluations between the departments A, E, absolutely necessary, especially important, and etc. You need to convert them to numbers using or assigning numerical values for each relationship, and it will be a symmetric one in that case. So when it is symmetric, you can use the upper triangle of this from two charts, so the lower triangle will all be 0. Now given this one, let me now show you how to open this add-in, layout add-in, and work with it. So the first thing, okay, if you double click on this file, so an Excel sheet will open and a security warning will pop up. So you need to enable the macros here. So this file contains some macros and you must enable it. So once you enable it, as you can see, there is this add-ins tab now, and if you click on there, you will see this a new menu button in which you have some options here. Now let me show you another thing. Since I already have an Excel sheet opened, it opened, the layout add-in is opened in this way. Let me close this one, this file. Let me save it and close it. And you see there are no Excel files opened here, and I'm just double clicking on this add-in and opening the Excel. So let me show you what you will see here. So when the Excel sheet opens again, it gives this security warning, enable the macros, and you see I don't see any Excel sheet here. The add-in is over here, but there is no Excel sheet. And on this open file, if you go and click, for example, new layout, or try to use this add-in, it will give you an error. You see, there's an error here. So what you need to do here is to go to this file and click on blank workbook. Once you have sheet, and then if you go to this add-in and start using that one, now it will work fine. Okay, so the first thing to do when you open the layout add-in, first open a new sheet, and then after that start working on. Okay, now this book, as you can see, it is currently not saved. Let me save it. So this is an important thing. Whenever you have these files, save it frequently. So I'm going to save it on a folder in my computer. Let me select this layout, and let's say that this is the problem XL6. Okay, now what we are going to do, in order to use this Excel add-in, you click on this menu and click on this new layout. Okay, and it gives you this new window. Here you give a name for your facility. For example, what are you designing? Is it a manufacturing facility? Is it a hospital? What is it? So for this one, we assume that our facility is a hospital layout. Okay, now how many departments you have in this? So if, let me open the problem data one more time. Yes, you see there are 8 departments. So what you do here, we select 8 departments. This number of fixed points, actually we are not going to use it, but if you set it, for example, 3 or 4, you can set some fixed points like columns of the building or elevator locations and etc., which you cannot play with it. So you identify them. But in our case, since there is no, I'm going to set it at 0. And the distance measure for us is the meters, so I'm going to select meters. Now if you click on here, make random problem, in order to demonstrate how to use this one, the add-in will generate the random problem for you. But if you don't click it, it will open a totally new one that you are going to enter all the data manually. Now let me demonstrate first of all this one with the random problem. When I click on OK, you see it created a random problem. All the flows, costs, and how to represent each department, everything is generated randomly. Now here, the yellow colored cells contains formulas or some data that you used to describe the department, so don't play with them. The yellow colored ones, we don't play with them. We are going to play with these uncolored or white cells. So again, this is the random data that is created. You can just go with this data and try the features of this one. But what I am going to do is I am going to use or solve a problem from scratch. So I'm not going to solve this random data. So in our original problem, so what I'm going to do is in problem Excel file, I am going to set this new layout. Okay, so it was a hospital, and then we had 8 departments with no fixed points and the meters, and I will unclick this one and click on OK. So now you see the data from two chart, the cost matrix and etc. They are not filled. We need to fill it. By the way, the cost matrix is all ones, meaning that if you just enter the flow, and if the cost of the flow is the same for between any pair of departments, you can use this one. Otherwise, if you assume that the cost is different, you can manually change whatever values you like. For example, 0.5 here, 1 here, and etc. Okay, so since it's not yellow colored, you can change it. Now let me turn back to the problem. We are going to represent each department by these many cells, and the thing is, let me round them up, round up these values, and with number of digits 0, sorry, round up these values with number of digits of 0, so all meaning that it is all integers. And as you can see, we need these many, which is in total, when you find the sum of these values, it is 125 cells we need to represent. Now these 125, we are going to generate a rectangular layout, maybe something like this. So we need to set the width and the length of this layout. So, and in total we need to have 125. For this one, again, you don't need to use exactly this 125, but it must be at least 125. So set me a length and the width so that the total is greater than or equal to 115. If it is too much greater, then in the end you will have some dummy or empty cells, and we want to minimize it. So closer to this 115, I see that 120 is a good number, so that I can, represent it by multiplication of two integer values. For example, it is 10 by 12, which makes 120. So I can set my total area to be 10 by 12 or 12 by 10. It is exactly the same. Okay, so what I did, I first identified how many cells do I need to represent my total layout, and then I identified what is a good number so that I can represent it as a multiplication of two integers. If this 115 is fine for you, you can use it. If it is not, you can round it, you can move it a little bit up so that you represent it by multiplication of these two integer values. Now I'm going to use 120. Let's return back here. So I am going to set the length of my department to be 10 and the width to be 12. And as you can see, when I change it, when I write this one, it is counting the number of cells by 120. Now look, what you can do here. If you want your cells to be, larger in size, for example, instead of 1, if I write here 5, you see the total cell requirement turned out to be 6. So this scale, actually it is the scale of one size of the cell. So 5 by 5, it is 25 meters square. So if you write here 1, and if you write there 5, between them there are 25 multiple of 25 difference. For example, if I write it here 2, it is not multiplying by 2. It is multiplying by the square of 2. So the total cell requirement is divided by 4 then. You see? So in this case, since I already identified that what for each department what is the unit square size, then I'm going to use it as ones. So otherwise you can enter this, for example, by 100 and 120, so, and then represent it by it should be around 3.3 to be have 10 cells, and then the total cell requirement will be closer to what we will have. Okay, but instead what I am going to say, okay, I initially make the calculations and identify the total cell requirement, and each cell now for me has a scale of 1, so I'm going to use a total of 120 cells. Now you see there are these 8 departments. You can write the names of the departments, for example, finance department, for example, surgery. Okay, so you can write their names here, or you can leave them as department 1, 2, 3, and etc. The second column here, you see you can have two options here, whether it's fixed or variable. Fixed means that when you write their F, this craft will not change its position. Whatever its position or location in the initial layout, it will be in the end. It is useful to solve some examples for which you have specific shapes. For example, this craft works with rectangular shapes, but if you want a different layout like L shape, T shape, and etc., you can use these fixed departments and still work with a rectangular one, but some departments are fixed, which are dummy, which are unnecessary departments. Okay, now here we are going to enter the area requirements for each cell, and from here we see that the area requirements we identified here, we are going to write these values. I'm just copying these values here and I will paste them as numbers. So these are the area requirements for the cells. Now the from to chart, again we need to enter the from to chart. Okay, as you replace the names of the departments, you see that they appear here also and here also. So from finance to surgery, if you go back to problem data, you see it is 11 and 9, and again I'm going to just copy and paste this one, otherwise you need to enter them manually. So I will enter this from to chart here, and for the cost it will be all ones for this example. Now I entered all the data. One thing you need to be careful about is this. So in total for your facility, you said that you are going to have 120 cells. Now the sum of these values must be less than or equal to 120. Okay, so now it is 115, this sum, if you look at here. So it is less than or equal to, which is fine. If it is greater, assume that for department 1 instead of 12 you write 20, and the total area requirement now is 123, more than this value. If you click on this button, which is the next one we are clicking on, it gives you an error saying that sum of areas of these departments exceeds the total available space. You see, so in that case you need to revert it back. I mean, you need to make sure that the total area requirements of the departments is less than or equal to this 120. Of course, we want it to be exactly 120, but because of these converting the areas into cells and rounding them up and etc., and having a rectangular shape 10 by 120, we included some dummy cells there. We wanted them to be as small as possible, but in the layout you will see them as empty in a minute. Okay, now we are ready, and the next thing is to click on this define facility. So when I define, a new window pops up. Here you have a number of options in order to solve this problem. What are they? First of all, which solution method you want to use, whether it is a traditional craft or the opt sequence. The opt sequence uses the idea of MC craft that we covered in the class, and traditional craft is again we covered in the class. So you pick one of these methods. For the initial solution, you have two options. Either you use this sequential, which is like an aldep-like initial solution method, and using a sweep width, this layout creates an initial layout for you, or you can set it as blank and enter it manually. Okay, so again, you may want to try both of these options. Here, the distance measure, you want to use rectilinear or Euclidean. You can click on them. Again, the plant width and plant length are written here. You can change here them also, but again, keep them as it is, because initially we already wrote them here. Now, when you use this sequential, you need the sweep width. So this department width tells you about this sweep width. So now our width is 12 and length is 10. For that, I'm going to use a sweep width of 4, and I'm going to use this initial layout, a sequential layout. Let's see what initial layout it gives. I'm going to use rectilinear distance and with traditional craft. So when you click OK, now as you can see, your problem data is given. Every department now is represented by a number and by a color. Their area requirements are here, and then you see these are yellow color, meaning that you don't use it. And as you can see, this is your initial department now, and we set the sweep width to be 4. You see it started from the top left corner and went down. So department 1 and then 2 and then 3, and it went up and then down again. Look, this is department 0, which is uncolored. These are the extra cells that, you know, the total area requirement of the department was 115, but the total area here is 120. So this 0 number department, which is uncolored, is the extra cells. Okay, now you see this number 2381 is the total distance-based score of the initial layout. And now we have a number of buttons over here. What you can do? You can click on, for example, this random layout, so that it will generate another layout for you. So let me click on it. You see it gave me another layout, and this is the cost of this layout. And as you can see, now it started with 7 and then 2 and then 3. Again, it uses the same sweep width and the same algorithm to find the initial layout. You can try it many times. You see the cost now reduced a little bit, another, you see. By changing on this random layout, at each time it generates another initial layout for you. Now when you click on evaluate, it gives you the value of the current solution. So for example, this solution is given to you. You are not happy with this one, or you want to manually adjust it. What do you want to do? For example, you want to make this layout to be 8 and this one to be 4. But you need to make sure that when you make a change manually, you preserve the total area requirements of each department. And now you want to understand what has been changed. When you click on evaluate, you see the evaluation, and you see the coloring is done automatically based on your change. Now you may want to, for example, see the flows between the departments. When you click on this show flows, it will show the flows in a relationship diagram. So a thick one means that the two departments have strong relation between them. A thin lines means that they have less relationship. And if you want these flows, the diagram to disappear, if you just click on evaluate again, you see they are disappeared. You may want to, for example, I will come to this solve at the end. You may want to, for example, try switching two departments and see what happens when you switch them. But in craft, in traditional craft, you can switch two departments if they are neighbors to each other, or if they have the same size. Same size means they require the same area. For example, department 5 and department 4. They are not neighbors, and this area requirement of 5 and 4 are not the same. So you cannot switch these two departments. But 4 and 2, they are neighbors, you can switch them. 8 and 3, they are neighbors, they are switch them. And for example 8 and 1, let me see which departments have exactly the same area requirement. In this example, unfortunately, we don't have two departments which require the same area, but assume that department 8 requires 20 and department 1 also requires 20 area, so their areas are the same. In that case, you can switch 1 and 8 also. Although they are not neighbors, since they require same area, you can switch them. So let's try to switch, for example, department 2 and 8. They are neighbors, right? So click on this switch and say department 2 and 8 and click on OK. You see this is the new layout where 2 and 8 has been switched, and you see the resulting total cost scoring of this change. Now, when you want to solve this problem, you are going to click on this solve so that it will start the craft algorithm. All the things that we did until now is our manual trials. But when you click on this solve, now it asks, do you want to see what's going on in each iteration of the algorithm, or do you just want to see the final result? If you click on do not stop, it will give you the final result. But if you click on the first one, at each iteration it will stop and tell you I'm switching this department and that, and this department and that. So let's try with this option. So stop at each improvement and click on OK. Now it says, look, I am going to switch department 3 and 8, and the estimated improvement or saving will be 84 units. Do you want to do it? Yes. The next one, switch 6 and 8. Look, 6 and 8, and saving will be 23. Click on yes. Now 6 and 8 has been switched. The next one, it's switching 1 and 4. They are neighbors, as you can see, and the saving will be 48. This is the estimated saving, by the way. The real saving might be different than this one. And next, it will do these switches until there is no further improvement. Now it's switching department 1 and 4 for a saving of estimated saving of 17. Click on yes, but when it switched, this one increased the cost. So it means that it didn't resulted in a saving because it was an estimated saving, but the real one is not. We covered this material in the class also. And when you click on OK, so this is the final layout given by the craft algorithm. It did 4 iterations. In the first iteration, it switched department 8 and 3, and then 6 and 8, and 1 and 4, and you see what happened to your cost. And finally, it reverted back 1 and 4, and this is the final layout, which is 2158. Now, is this the optimal solution? No, it is not the optimal solution. This is a heuristic algorithm, meaning that the starting layout might affect your final result. What else? The method that you use, whether it's traditional craft or opt sequence and etc., it might change your final result. The unit square size, the cell size, it might end up with a different result. So you need to try different options, and if you can see this final layout, look at department 1 layout. How weird shape is it? Or department 6 layout. It's a weird shape. It is not useful actually in real life. So you need to manually adjust this one. Okay? It is a manual adjustment is necessary, and when you manually adjust it, for example, this 6, you may want to move these 2 6s over here, and then instead of them you write 2 2s here, so department 6 has a better shape. You try to make each department rectangular shapes by manual adjustments, but of course this will end up with a different cost rating. So when you come up with your final layout, you may want to enter it here and click on evaluate, so it will give you the final layout. So what I'm going to do is, for example, I will move these 6s to here, and then instead of these 2 6s, I'm going to put department 2 here, and then click on evaluate. Look at this cost now, and when I click on evaluate, it's increased a little bit. But again, the department shape or department shapes are better. Again, I'm going to move this 6 also over here, and then instead of that I'm going to put another 2 here. Now you see the departments are more rectangular shapes. Now this part, again, it is not good. Maybe I will move this 6 to here and also here, and instead of these I'm going to put 2 3s here. So the department 6 has a better shape, but department 3 is not good now. And if I click evaluate, it is increased a little bit. So by these manual adjustments, you need to satisfy. Look, department 4 is a very good shape now. Department 8 is not bad. You can manually adjust it between 5 and this. Department 7 again is not bad, but department 1, department 6, department 3, you need to adjust them. Okay. Now, the thing is, this layout add-in, it works well with Windows, but for Mac computers, you might have problems. So if it doesn't work, these macros might not work with macOS. In that case, I suggest you to use Windows computers. Okay. Secondly, now in this example, I asked the layout add-in to create the initial layout using this algorithm. Now I am going to use this method, so I will leave it blank. I am going to use traditional craft, everything else is the same, but I will say that the initial solution to be blank. Now when I click on this one, of course this old sheet now will be changed. It created an empty area for me to enter the layout. You see? Now I am going to enter my initial layout manually. How? You see, if the first department, which is finance, requires 20 cells. So I am somehow on this area, which is 10 by 12. I need to add 20 cells for the first department. So you may want to, for example, start from left or down or in the middle, wherever you want. Of course, it is better to look at the from to chart to see which department is more important, so that you may want to fill this department into center, and then start filling. Okay, department 1. So let this cell be department 1. What I am doing is I'm just writing the number of the department. Okay, department 1, 1, 1. So now I added 4 cells. I'm going to add 20 cells. So let's say you continue to add these up to you reach 20. So let me add these also. Now the total is 20. And this is finished. Now go to second one and start adding the second one, 13 cells. So second, 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 until you reach 13. And of course you need to satisfy the rules. What are the rules of these location? Contiguity rules, connectedness rule, and then enclosed void rule. Okay, otherwise if you end up with a layout which doesn't satisfy connectedness, this program might not understand that, will not give you an error, but will continue to work with it, but the final layout will be not feasible. For example, until now we added these 10 cells, and the other 3 cells required by this department 2, let me add them here. Now you see this part of the departments, the same department, they are not connected. Then again, when you try to solve after finalizing everything, when you click on solve, this crowd will try to solve it, but in the end the final layout again will not be connected. There will be errors, mistakes, and such. Okay, so pay attention to this one. Again, you need to enter all of it. I previously prepared a layout. Okay, of course here there is the colors also, but you don't need the colors. We just need the numbers. Okay, assume that this is the initial layout. Again, this department 1, I allocated 20 units for the department 1, and for 2 it is 13. and you see there is this department 0, you may even leave them empty. Okay, what are these? These are extra cells. We record 115, but in total the space allocated is 120, so 5 of them are empty. So you can copy and paste this layout here. Sorry, okay, it is the other way around, so I'm going to paste it by transposing. So let me do it here first. So the number of rows and columns was different, so let me copy and paste it here. Now we have the layout. Okay, this is the initial layout. As I told you, you need to write these one by one, the number of cells, into the empty layout. Now what we can do, first we might want to see what is the current cost of this one. When you click on evaluate, you see it colors the departments to see it visually, and this is the initial layout. Now if I click on solve, for example, this time I will click do not stop, just show me the final, and click on OK. You see it made 2 iterations. It improved the cost, 3 iterations, and improved the cost from 2,300 to 2,195. So this is the final layout, you see, and its value is 2,195 of this initial layout. Again, you may want to, for example, go with some random layouts, and then starting from this random layout you solve it and try to find a better. It is 2,196. Okay, find another random layout and then solve it, and then try to find better solutions. Sometimes you see it finds even worse solutions, or sometimes it can find better solutions. So starting from different solutions may end up with different results. Okay, and also if, for example, you want to use the opt sequence method, okay, then you see leave blank option is not there. It means that it will generate the initial layout itself and use the opt sequence method. And then you see this is the initial solution with this cost or scoring. And when I click on solve, you see it always uses the same sweep width, and the total value is 1957, which is something good. And you can click on this random layout and solve one more time, and you may want to see what's going to happen. Another random layout and solve it, and what's going to happen even better maybe. And one thing about this opt sequence method, which uses the MC craft, the department shapes are better, as you can see, compared to the traditional craft. Okay, and again, as I told you, once you do something with this one, always save it. Secondly, your original problem data, for example, you came up with an initial layout, save it to another Excel sheet. When you need it a second time, you can just copy and paste it here, because what will happen when you solve it, your initial layout will be changed and you cannot recover it. You need to write it one more time manually. So make sure that for your all tests, the results, you save them as separate Excel sheets. Your trials, save them as separate sheets, and whenever you do something, save them so that you can later on work with them. Final thing, this add-in works well, but sometimes it ends up with problems. It ends up with something or some weird layouts. Let me use, for example, this traditional craft. Click on OK, and for example, let me try to switch department 2 and 6. What it will say: 2 and 6, they don't have the same size and they are not neighbors. So when I click on, you see they are not adjacent and they are not equal. It doesn't change. Let me change department 5 and 7. Okay, they are neighbors. So let's switch 5 and 7 manually. And what you see these department shapes, and you can see evaluate to see the value of it. Let's change, for example, department 3 and 4. 3 and 4, and switch it. You see, since they are adjacent, we could switch them. Now let's switch department 7 and 4. So I am trying to obtain weird shapes of the departments. You see department 4 shape, what kind of layout it is. And then we can even switch department 5 and 4. Okay, 4 and 5. Switch. And you see, now what happened? Look, department 4 and department 4. It's not connected. So it's wrong, it's infeasible. This craft add-in ended up with an infeasible layout, and it might be, so this algorithm is not super complex or super well established. This is just an add-in. It might end up with this one. You need to identify if the final layout is feasible or not. If you fell into this infeasibility, now if I reswitch 4 and 5, let's see what happens. I reverted back so that I can continue from here. Sometimes it might even create another big problem when you try to switch. Okay, let's try, for example, this one. Switch 4 and 5. Now we have this one. Now let's switch 4 and 6. Okay, since they are adjacent, 4 and 6. Now what happened? Department 6 is disconnected. You see? And it creates such problems. So that's why you may want to make sure that you understand what's going on here. If you end up with an infeasible layout, don't give it as your final layout. And when you come up with this final one, of course you need to manually adjust the departments so that they have good shapes. Secondly, this is the block layout. From this block layout, you need to provide the detailed layout, and in the detailed layout you need to have all the information about the departments, like their aisles, entrances, the inside the department layouts, and etc. Okay, that's all for this layout. Thank you for listening.